afternoon, jazz guitar fans, fellow forum members. The workshop is pretty much finished. There's no ribbon cutting moment. It is just that this video is long overdue. I had been hoping that there would be a definitive point where the workshop would be done, but actually if things have gone on, I've realized that that's not how this works. So over the last few months, I've been doing a little bit in the workshop, but mostly working on tooling and stuff for the guitar manufacturing. And I've thought, oh, shall I make this final episode in this workshop build series now? And I thought, oh no, I'm going to put some things over there and I've got to do something here. So I've kept pushing it back. And I think it's finally now at the point where I can say it is done, or I am no longer focusing on building the workshop. I am now focusing purely on manufacturing guitars. So let's have a look around the workshop and see what I've been up to. Let's start with the assembly benches. There's two of them at the moment. There's probably going to be another one here. And what I'm hoping is that the guitar will go through different stages of manufacturing and the benches will be associated with each stage of that process. I'm not entirely sure how that's going to work out because, again, all of this is just guesswork on my part. I'm just trying to project forward into the future, imagine what I will be doing, trying to imagine the best way to do it, and then working back from there. This, for example, could be where the tops and the back plates and the sides are glued together to make the box. This could be where the neck work is done. Another bench here could be where the binding work is done, and there could be a final bench for assembly. At the moment, this is the neck area, so all of the tooling for neck work and fret work is here, but I'm actually not going to be using quite a bit of that process. I'm going to design my own process, and hopefully if it works, fingers crossed, it's going to be brilliant. This is just a bit of a dead area, really. It's just an odds and sods collection. I'll give anyone 10 points who can tell me what these part bins have in them. Not this one, because I actually even don't know myself. This is the vacuum forming area. So gluing will happen here, butt joining, and some jigs will go on there, and then they'll go into the vacuum. So yeah, that's about it for this room. Assembly, vacuum forming, and then we've got the wood cutting and the workshop at the back here. So let's go and check that out. There's a couple of new additions to the workshop out the back here. Get the lights. So as you probably remember, those who've been following this series, I built this wall. I will paint it probably, but do you know what? I've got to crack on with making guitars, otherwise I'm just going to get way too far behind. I've built this drawer area here and bench top for the Hegner disc sander and the scroll saw. There's also a bobbin sander here. So this area is generally for kind of fettling with little bits, nuts, bridges, maybe shaping of pick guards in a prototyping way, because obviously most of that's going to be done on CNC because of the accuracy. So it's there if I need to do some shaping work. And this is a tooling that I designed and manufactured or built for making veneers. It's a sliding carriage, much like a meat slicer in a supermarket. And I need to put a little handle on here, but you wind this in and the face or the fence goes backwards and forwards. You get a piece of wood. It's got a vacuum formed clamping face. So the wood gets sucked onto the face of this and then you move it backwards and forwards, taking off veneers as you go. Another new part is this pillar drill, which is bolted to the stand here. Don't worry, it's all safe. And we've seen that. This is a custom dust extraction system that I made for the CNC machine. A little bit convoluted, but I'll tell you why in a minute. This is a microparticle filter to just try and stop any particles that have escaped extraction systems from building up and getting too much in the air. And this is the wide belt sander. Here we have the panel saw, which people have already seen, and CNC machine. This is the huge micro filter for the CNC, And then there's a two-stage, there's a cyclone there. So it comes up into the cyclone, through the impeller and down into the final filter phase here. I put the motor on the other side of the wall just to try and stop some noise coming over so I can hear the cutter, which is quite important. And then finally, my Harry Potter floating stand for the controller PC. It's just basically a little TV arm so it can, anyway, not that important. That's not the star of the show, is it? Dehumidifiers over there. Wood, this room and this room are both climate controlled. They are sealed from the main area. But yeah, I think that's it. So coming back into the workshop, the main area, here is a lot of the sealing that I've done between this remaining wall and the machining room in the back. So all of that's been panelled off and along there. And again, I built this wall to separate that room from here as well. Upstairs, we've still got the mezzanine, but that's not got much going on at the moment. It has the dust extractor up there. I've turned it into a bit of storage. I will build the spray booth up there, but I'm not going to do that until I've manufactured some parts. And I apologise for not getting this video out sooner, but I've been working on a lot of exciting things and I'm going to show them to you now. I'm going to talk about materials that I've been working on, formers that I've been making, CAD work that I've been doing, what I've learned so far, and what my hopes are for this venture. And I suppose it's probably better to talk about that bit now. I've been collecting and scanning as many of those kind of seminal guitars that I can find, and that scanned data is being used by me to analyze those guitars. When I 3D scan a guitar, I can copy every minute detail of that guitar down to 2 microns of accuracy. And then I can reverse engineer that in CAD. So I can take the top plate off, I can take the bottom plate off, I can take the neck off, I can straighten the neck, I can take the fingerboard off, I can do all sorts of weird and wonderful things. And I also have a device that allows me to measure the thickness of wood. So I can measure the thickness of the sides of a guitar, I can measure the thickness of the back plate. And of course, these are areas that generally most luthiers cannot access unless they were to literally start pulling the guitar apart. If we have a look at these formers, this is a 16-inch former for a Terada Fujigen jazz guitar, and they've been using this shape since, I think about the mid-70s. It's taken me about a year and a half of really hard learning on CAD to be able to produce this. It was much more difficult than I thought. You cannot just scan a 3D scan a guitar and then have an arched plate because the guitars move over time. An example of that here is that if you see this area on the waist, there's no lip, but there's a lip here. If we look right in the front here, there's no lip there in the cutaway, but there's a lip here, quite a big one of about 2 mil. So plates move over time, obviously due to stress and environment. So if I scan a guitar, I can't then use that as the former, because if I put my veneer stack on there and laminate it, it will just create a warped former, a warped plate. So it's taken me a long time in CAD to learn how to take that warping out and put the shape back to its original shape and, to be fair, improve on that shape. So if I give an example, this is from a JP20. Under the scan in the CAD, bearing in mind the great thing about CAD and the bad thing about CAD is that if you see this in real life, you think that's nothing, but you can zoom into that on CAD and suddenly it becomes quite big. This plate was slightly lower in the arch on this side than it was on this side. And I want the arch to be perfectly symmetrical because that improves the integrity of the arch, which might allow me to lighten up on the bracing. It might allow me to make the wood a little bit thinner. might allow me to do some other things. It might create a more responsive laminate plate. So what I've been able to do is cut the body, talking in CAD here, into 4 sections, take this section and just take some of the really important stats that make a plate what a plate is. So we're talking about the height of the center of the plate at the widest points. We're talking about the general profile, the general width of the arch. What I was able to do is put horizontal constraints here and here, take this section, remake it to the original shape, but just improve the arch, the way the arch moves just a little bit, make it a little bit more flowing, a little bit more consistent. And then I was able to take that and mirror it over to this side. This is a perfect image of this. And then up here, I was able to blend this back in. And so you can't see it, but if I was to show you this plate this way, you will not get a more symmetric arch. Okay, so let's talk about veneers, given that they are the constituent components for making up a laminated arched plate. So there are 2 types of veneer that you can acquire. One is knife cut. That's an industrial process that uses massive machinery, takes huge bits of log, and it either slices them against a blade in an up and down motion, or it puts the log in some rotating rollers that has a long knife edge, and as the tree is rotated, the knife skims off the outer layer and produces one long flowing carpet of veneer. The knife cut veneer has pros and cons. The pros are that it's widely available, it's cheap because you don't need to buy any machinery to make it. You have a huge variety of wood because buying operation will have veneer cutters at the very top of it. You will also have probably the widest and the cheapest way of buying incredibly figured veneer. And I mean stuff from burl to bird's eye to cat paw to rippled to quilted, you name it. You can buy what's called a decorative veneer. So let's talk about the 2 types of standards in the knife cutting veneer industry. So the first type is called construction veneer. It's 1.5 mil thick and it is plain. The second type you can buy is decorative, and that is 0.06 mil thick, so just under half as thick as the construction veneer, and that is used by companies like Gibson. If you have a Gibson veneer stack, you will have a decorative veneer of 0.6 or 0.5 mil, you will have 3 construction veneers of 1.5 mil, and then you will finally have another decorative veneer of about 0.5 mil. So if you add those up, you come to about 5.5 mil thick, which is about the thickness of a Gibson arched plate. So if you're a huge manufacturer like Gibson, it's so easy for you to go to the knife cutting veneer industry and say, hey, give me X amount of square meters, or I don't know if they use yards in America, of construction veneer, which comes in at 1.5 mil, and give me the equivalent of decorative veneer in this particular type of figuring that comes in at about 0.5 mil. If you look at an old Gibson video of the workshop, there's a moment where you see a lady standing next to a stack of what looks like parchment paper that's all wrinkled as if it's got wet and crumpled up a bit. Here is an example of what I mean. This is actually about 1 mil thick, but even still it starts to change its shape and become a little bit distorted based on the climate, obviously, and the grain structure and direction will create changes the thinner the veneer gets. So those are the 2 types of veneers in the knife cutting industry, construction and decorative. But if you wanted to make a guild plate, well, their internal veneer stack is made of 1 mil thick veneers. And so we have a problem. Resawn veneer is more expensive to produce because the production of it is generally going to be down to you, but it also gives you a phenomenal amount of control. And the process is you will take a piece of wood like this that you can buy from a timber yard in much longer slabs. You can cut it down on a panel saw or a band or a table saw into the size you want. So for example, this is probably just under half the width of it. So that's half the width of a 16-inch jazz guitar. If I book match that, it will do the other half. So you put it on your bandsaw, you take your thickness, say 1 mil, and then you slice your veneer off like so. Now this actually came from here, and this is a 1 mil thick veneer made on a bandsaw. Now you can see the difference in quality already. This is Poplar, purchased from the biggest supplier of knife cut veneers in the UK. This is Poplar, manufactured by me. Now, I know that a lot of this material, especially Poplar, is part of the internal veneer stack, but for me, every layer counts. I would rather have this, and I would rather have to go out and buy a big log, cut it down on the panel saw, take it to the planer, put a flat face on it, take it over to the bandsaw, slice some veneers off it, and glue them together, than I would use this, which I just have to click and buy online. My goal is to create the highest quality veneers you could possibly buy. I'd like to touch on vacuum forming versus male and female mold clamping. And a lot of builders use the male and female molds, and some bigger companies like Epiphone, and I'm talking Epiphone before being purchased by Gibson, would use vacuum forming. Now, it is my opinion and / belief that if you use vacuum forming, you are going to create a more consistent pressure on the surface that you're trying to shape, and therefore you are applying more even pressure to the glued surfaces as they're being shaped. So I think it's just more consistent. As an example, if you have this little piece of veneer here and you're going to glue it in a little former, male and female formers, you see here on this edge it's about probably about 3 mil thick, and on here it's about 1 mil. So you've got a 2 mil difference between here and here. Now if you take 5 of these and they all have the same inconsistency and you stack them on top of each other, you're going to have 5, 5, you're going to have 25 mil at this end, and you're going to have 5 mil at this end. You can draw that math down to 1 mil here and 0.5 mil here. But if you do, that's 5 mil on this side and it's 2.5 mil on this side. So you've still got a 2.5 mil discrepancy, which is not good, because if you then put that on top of your male former and then put your female one on top and clamp it, you cannot apply even pressure to the glued surfaces because that it's no longer fitting properly in your mold. So with vacuum pressing, you remove that problem. Now, I don't intend to have veneers that are thicker on one point than the other, and I've obviously bought some machinery and invented some rather over-the-top devices to stop that. That is the point that I'm trying to make. Every part in the chain has to perform to its best. If I can combine these skills that I'm learning, let's call it digital luthiery, and I can combine those with the finest quality veneers, the finest and most accurate machines, I can make the highest quality veneers, laminate, arched plates I think the world's ever seen.